there's a very important topic that I want to cover is called level curves. So we know that the set of on the point x, y, z, or f of x, y in the space for x, y in the domain of f is called a graph of f. And the graph of f is also called the surface z equal to f of x, y. So for instance, this is the graph of a function. So the function of two variables are represented by surfaces in R3. However, such functions can be represented in a very interesting way, which is used to make topographic maps. So topographic maps are the maps that you see when you go hiking. So consider a surface defined by the function z equal to f of x, y. Now imagine stepping onto this surface and walking along a path on which your elevation has the constant value z equal to z0. So you're basically here and you're going to walk around this path. And the elevation of this path is z equal to z0. So the path you walk on the surface is part of something called a contour curve. The complete contour curve is the intersection of the surface and the horizontal plane z equal to z0. When the contour curve is projected onto the xy plane, the result is the curve f of xy equal to z0. So you have this path that you're taking, and this path elevation is z equal to z0. So this is called the contour curve, and then you project this contour curve onto the xy plane and you have something called the level curve. And the level curve is of the form f of xy equal to z0. And then you're going to repeat this process with different constant value of z. That is, you take a different path at different elevations. So here, the original elevation you may have is z equal to z0 here. You take another path for this elevation of z equal to z1. All of these contour curves can be projected onto the xy plane to get level curves. A collection of such level curves corresponding to different value of z provides a useful two-dimensional representation of the surface. And the level curves tell you the changes in the z directions. In a topographical map, the contour lines or the level curves are close together, implying the surface is steep. Or the contour lines or the level curve are far apart, implies the surface is flat. So the next time when you go hiking and you have a topographic map, you understand where it's coming from and what it's telling you. So in the next example, I'm going to show you how to find the level curves of the function and sketch the level curve. So I want to sketch the level curves of the function of the form f of xy equal to 6 minus 3x minus 2y for a different value of z. That is, okay, in this case, is k equal to negative 6, 0, 6, 12. So when k is equal to negative 6, right, so what you do is you substitute f of x comma y equal to negative 6. Right, so you have the functions to be 6 minus 3x minus 2y, and this is equal to negative 6. This looks like an equation of a line, so I'm going to solve for y in terms of x. So that is, you have negative 2y equal to 3x minus 6, or negative 2y equal to 3x minus 12. Or y is equal to negative 3 half x plus 6. So this is the equation of the line with slope negative 3 half and the y-intercept to be 6. Now you have the next value of k, which is 0. So we're going to do the same thing. When k is equal to 0, you do 6 minus 3x minus 2y equal to 0, and you're going to solve for y in terms of x because the equation looks like the equation of a line. And you get that y equal to negative 3 half x plus 3. When k is equal to 6, you have 6 minus 3x minus 2y equal to 6. Therefore, y is equal to negative 3 half x. When k is equal to 12, you have 6 minus 3x minus 2y equal to 12. And then you solve for y in terms of x, you get negative 3 half x minus 3. So all of this value of k will help you produce a set of equations of lines. Okay, those are the level curves of the surface of the form 6 minus 3x minus 2y. That is, when you look at this surface from the top down, you will see the lines parallel to one another. So I'm going to plot these lines on the xy plane. So this is x-axis, this is y-axis, this is the origin. So when k equal to 0, so when k equal to 6, you have y equal to negative 3 half x. So that is So I'm going to start with y equal to negative 3 half x. I'm not going to draw it accurately. I just want to show you what the level curve looks like when you plot them together. So I just know that the line y equal to negative 3 half x is the line going through the origins. So this is the case when k is equal to 6. Now you're going to have a bunch of other lines parallel to this line y equal to negative 3 half x because all the lines have the same slope. So we're going to start duplicating this. So for instance, this is the line y equal to negative 3 half x plus 3. This is the case where k is equal to 0. You have this the line of the form y equal to negative 3 half x plus 6. This is the case where k is equal to negative 6. And this is the line y equal to negative 3 half x minus 3. This is where k is equal to 12. Alright, again, when you look at the plane of the form 6 minus 3x minus 2y from the top down, this is what you're going to see, a bunch of lines that is parallel to one another. So the collection of these lines called the set of level curves, or for short, just level curves. This graph represents the level curves of the function f of x comma y equal to 6 minus 3x minus 2y. So let's continue with the next example. So in this example, we want to sketch the level curve of the functions f of xy equal to square root of 9 minus x squared minus y squared for the value of k to be 0, 1, 2, and 3. So to consider the level curve of the form, so consider the level curve of the form square root of 9 minus x squared minus y squared equal to k. Now eventually we're going to solve for x and y, and to do that I'm going to take the square on both sides of this equation, and I'm going to get 9 minus x squared minus y squared equal to k squared. Then I'm going to solve for x squared and y squared. So negative x squared minus y squared equal to k squared minus 9. Multiply negative 1 on both sides of the equation. I'm going to get x squared plus y squared equal to 9 minus k squared. We have 4 different choices of k. That's k equal to 0, 1, 2, and 3. So in the case where k is equal to 0, you have that x squared plus y squared equal to 9 minus 0 squared, or 9. So this is circle center at the origin with radius 3. So circle center at the origins with radius 3. Now, in the next scenario, when k is equal to 1, you have x squared plus y squared equal to 9 minus 1 squared equal to 8, or this is the circle center at the origins with radius square root of 8, or 2 times square root of 2. When k is equal to 2, you have x squared plus y squared equal to 9 minus 4 equal to 5. So this is the circle center at the origins with radius square root of 5. And for the last case, when k is equal to 3, you have x squared plus y squared equal to 0. So basically this is just a point at the origins, because the radius is equal to 0. Alright, so we can actually visualize this level curve. So it's just going to be a bunch of circles centered at the origins with different radius. Here you're going to plot the xy plane. You have at the center at the origins here, which is the case when k is equal to 3. Notice that square root of 5 is less than 2 times square root of 2 and less than 3. So therefore the next circle that we're going to draw is the circle center at the origin with radius square root of 5. So again, I'm not going to draw to the exact value of square root of 5. I'm just going to sketch out the level curve so that you understand what the surface look like when you look at the surface from the top down. So this is the circle center at the origin with radius square root of 5. The next one is the circle center at the origin with radius square root of 8 or 2 times square root of 2. And the last circle in purple is the circle center at the origin with radius 3. So I want to note that for this case, k is equal to 0. For this circle, this is where k is equal to 1. For this circle, this is k equal to 2. And the point at the origin is when k equal to 3. So this is the level curve of the functions f of xy equal to square root of 9 minus x squared minus y squared. So there's infinitely many level curves if you choose infinitely many value of k. But remember, when you look at the functions here, this is square root function, you have to find the domain of the function and the range of the function so that you can choose the correct value of k. As you can see, k is going to be between 0 and 3 only. Now we're going to move on to the last topic of this lecture. It's about functions of 3 variables. So graphing function of 2 independent variables require a 3-dimensional coordinate system, which is the limit of the ordinary graphing methods. Clearly, difficulty arises in graphing function with 3 or more independent variables. For example, the graph of the functions of the form w equal to f of x, y, and z resides in 4 dimensions. So we basically cannot really visualize the 4 dimensions. But what we can still do is we can still visualize something called the level surfaces. So what we have learned so far up to this point is if you can visualize the surface in 3 dimensions, you can project that on 2 dimensions and get the level curves. Now if you visualize the function in 4 dimensions, it can be projected into 3 dimensions and we can get something called the level surfaces. So technically, that's the best that we can do for functions of 3 variables or more than 2 variables. But we can divide this type of functions algebraically. So let D be the subset of R3. So D in this case is going to be the domain of the function. A function f of 3 variable is a rule that assigns each order triple x, y, and z in the domain a value w such that w is equal to f of x, y, and z, and w has to be in the real line. So again, D is the domain of the function. Here you have 3 independent variables and 1 dependent variable. And the set of all the output of f, or w in this case, the range. So the level surface of the function of 3 variable is defined to be a set of points satisfying the equation f of x, y, and z equal to k, for k is some constant that you can choose to visualize the level surfaces. In the next lecture, we're going to look into the calculus of function of several variables. So that's it for me. Please let me know if you have any questions. Thank you.